Hello, welcome to 3A, the classwork. All right, simplifying negative radicals. So to simplify a negative radical, break it up. So you got -1 and 64. You can break up square roots when there's multiplication underneath the square root. So we have the square root of -1 is I. So this right here becomes, that's I. We're going to represent that as I. Looks a little nicer as I. And then 64, the square root of 64 is 8. So this is ultimately going to be 8i. The next one, we have square root of -1 and 54. Square root of -1 and times the square root of 54. Square root of -1 is I. 54 is not a perfect square, so we're going to have to break that down. You can use the trees if you'd like. And any two numbers that multiply to get the number above is what you're looking for. And you break it down to prime factors. Now we're looking for, it's a square root, so we're looking for pairs of the prime factors. So there's only one pair. It's the 3. The 3 is going to come out as a 3. The I is going to come down, so on the outside of the square root. And then we have a 3 and a 2 that are left over. Those are going to get multiplied together. So it'll be 6, and we're going to put that underneath. So it'll be square root of 6. So you have 3i square root of 6. Next one, we have square root of -50 x squared. So -1 times 50 x squared. Square root of -1. Square root of -1 is I. Square root of 50 is 25 and 2. 5 and 5. You can also stop anytime if you see a perfect square, like square root of 25 is 5. You ultimately know that the pair is going to be end up being 5. So we're going to have a 5 on the outside. We're going to have an I on the outside of the radical. Well, I forgot this x. X is going to break down to x times x. That's x squared. So you have a pair of x's also. So ix square root, and there's a 2 left over, so that stays underneath the square root. You can write the I or x first. It doesn't matter to me. All right, next one we have square root of -49. So we have the square root of -1, 49, and x squared. So the square root of -1 is I. Square root of 49 is 7. And the square root of x squared is x. So that's going to, let's put that in. So the constant first, so the number first, x. I or ix, doesn't matter to me. Next one, we have square root of -1. Oh, not 128 and x to the 5th. So square root of -1 is I. 128 breaks down to 64 and 2. I have a tendency to circle the prime factors. Prime factors means only 1 times itself is the only way you can get that number. All right, so now we're looking at, it's a square root, so we're going to look at pairs. So a pair of 2's. So or you could think of it as 2 times 2 is 4, and the square root of 4 is just 2. So 2 times 2 is 4, square root of 4 is 2. And another 2 times 2 is 4, square root of 4 is 2. There's a 2 left over. Let's not forget about this I here. Forgot about this x to the 5th. 1, 2, 3, 4, 5 x's. That's x to the 5th. Extrapolate out and multiplied. 1, 2 pairs, so x times x. And what's left inside? We have a 2 left inside, that's not part of the pair, and an x. All right, let's simplify this down. 2 times 2 times 2 is 8. X times x is x squared. I switch those around. With multiplication, that's one of, you can switch around any, you can actually, it doesn't matter that order. All right, next one, we have -5 on the outside. That's going to stay on the outside. There's a multiplication there. And we have square root of -1 times 98 times x to the 4th times y to the 7th. So we have 98 is 49 and 2, 7 and 7. So 7's our prime, 2 is prime. X to the 4th, that's 4 x's. X to the, or y to the 7th, if you want to write them all out, 2, 3, 4, 5, 6, 7. You don't have to. If you can do this in your head, that'd be awesome too. So on the outside, we have the 5. So negative 5 on the outside. We have the square root of negative 1 is I. We have, let's do the x's, 2 pairs, so that's going to be x times x. 1, 2, 3 pairs of y's, so 3 y's coming out. And number-wise, I never forgot about that, is 7. I should have done that first, but that's okay. We'll rewrite it at the end. So we have, what do we have here left over? We have a 2 and a y. So 2y inside. Let's clean up the outside. So negative 5 times 7 is negative 35. X times x is x squared. Y times y times y is y to the 3rd. I square root of 2y. There's your final answer. Pretty wild. All right, next one. We have a to the 3rd. Don't forget about that negative, is the square root of negative 1 times 6, a to the 8th, b to the 18th. So we have square root of negative 1 is I, so that's a to the 3rd times I. A to the 8th, how many pairs can you take out of a to the 8th? Well, 4, so another way to do this is just a to the 4th. How many pairs can you take out of b to the 18th? Well, you can take out 9 of them, so that's going to be b to the 9th. And the only thing that's left over is the 6, because the 6 doesn't break down, it's just 3 and 2. It doesn't simplify with the radical. So we have a to the 3rd times a to the 4th. So like bases, with multiplication, you add the exponents. B to the 9th, I square root of 6. Next, we have 7x, don't forget the negative 1, times 18, x to the 3rd, y to the 8th. So the only thing I'm going to do is the 18, I'm going to break that down so it's a little easier to see. If you can do the perfect squares in your head, you don't have to do this, the tree. Like if you saw that there was a square root of 9 in 18, and the square root of 9 is 3, that's great. 7x is already on the outside. We're going to take that 3. The x to the 3rd, how many pairs can you take out of x to the 3rd? There's 3 x's, so only 1 pair, so only 1 x. There'll be x left over on the inside. How many pairs can you take out of y to the 8th? Should be saying 4, so that's y to the 4th. Don't forget the I, and then what's left around over on the inside? The 2, and one more x. Let's clean this up. 7 times 3 is 21. X times x is x squared. Y to the 4th, I square root of 2x. All right, finding mistakes. You have to do the problem to find the mistake. So let's work this out. 80 is 8 and 10, 4 and 2. So I'm breaking it down into prime factors. It's the easiest way to see how you can simplify. So I have a negative 6 on the outside. 2 2's, so it could be, you could multiply them, just have 4. Otherwise 2 times 2. The negative 1 is I. Then we have x. There's 5 x's. X to the 5th. How many pairs? You can take out 2, so that's x squared. So the other x came from out here. We have y to the 6th on the outside. And then how many pairs can you take out of y to the 16th? Well, that's y to the 8th. Boy, this is getting wild. Square root, what's left over? A 5. We weren't able to take out all the x's, so there's an x left over. And that's it on the inside. All right, so we have negative 6 times 2 is negative 24. X times x squared is x to the 3rd. Y to the 6 times y to the 8th. Like bases, so like bases are the y's. With multiplication, you add the exponents. So y to the 14th square root of 5x. Let's check out what we did. Negative 24, negative 24. I, perfect. Out of the fifth, oh, there we go. The exponents, not right, and the negative. So there's two spots. They did not take out the negative with the I, and the exponents are not the same if you see. All right, so that's exponents and the negative. All right, last one. 625. Some of you may know this. I believe it's a perfect square. Otherwise, we have 5 times 125. 125 is 5 times 25. 25 is 5 times 5. So look at all these 5s we have here. You have 2 pairs. So on the outside, we have a 3 already, times the 2 5s. You could just multiply them together. It's not a big deal. X to the 5th, that's already on the outside. The negative comes out as I. Square root of x to the 4th is, never mind, we don't do the square root. Let's get rid of that. We're not done simplifying yet. X squared of x to the 4th is x squared. And how many pairs can you take out of y to the 20th? Well, y to the 10th. There's no square root left. Sweet. 3 times 5 is 75. X to the 5th times x squared is x to the 7th. So add those exponents. Y to the 10th and I. That's your final answer. So it looks like a negative is wrong, and we didn't simplify here correctly, and there's no I. All right, cool.